Welcome to Mountain Man Fungi. There is a pharmacy out in the natural world that has the potential to alleviate just about any problem that the human body can have. This mycopharmacy, if you feel so inclined to call it so, has an almost otherworldly, magical, unbelievable potential to heal the human body. But this mycopharmacy is very real, very true, and grows all around the world in abundance. Please join me in this discussion about the pharmaceutical chemical potential that is in the fungal kingdom. Disclaimer, I am not a medical professional, and any supplements or substitutions of existing medications should be consulted with a medical doctor. The most known medicinal chemical, and most of which a lot of scientists and mushroom companies base the potential benefits of fungi on, are called polysaccharides. Polysaccharides are made up of a very diverse group of macromolecules that are linked by glycosidic bonds. The most common polysaccharides found in fungi are chitin, hemicellulose, beta-glucans, alpha-glucans, mannans, xylans, and galactans. The highest efficiency of bioactivity is in the beta-glucans, specifically beta-1,3 and beta-1,6, which have a triple helix structure, and the structure of the configuration determines the immunomodulatory properties. The beta-glucan content is determined by species, environment, maturity, and can range anywhere from between 3.1% to 46.5%. A couple examples of species-specific beta-glucans are lentinan, found in Latinula etos, which are shiitake mushrooms, Preston, found in Trametes versicolor, turkey tail mushrooms, and Pleuran, found in Pleurotus austrius, oyster mushrooms. Lots of information on polysaccharides are available to the public, and for a more detailed overview, I highly suggest looking at the link that I provide in the video description. However, I do share some caution if you're using supplement companies for your polysaccharide data to determine what's best for you, because from things that I have learned from Host Defense and Fungi Perfecti, founded and ran by Paul Stamets, who is a very respected mycologist and very well-informed sources, shows that testing for beta-glucans is very unreliable due to the current testing methods only being able to detect soluble beta-glucans, leaving unsoluble beta-glucans a mystery as to how much is actually in the fungi being tested. Up next is a potential super micronutrient, ergothioneine. Ergothioneine was first isolated from the ergot fungus, Claviceps purpurea, in 1909, and grown in a medium of acetate. Ergothioneine has been aptly given the nickname the longevity vitamin. Research suggests that it can scavenge reactive oxygen and nitrogen, mitigating oxidative damage to biomolecules and oxidative stress. A transport protein from the gene SLC2284 has a high affinity for ergothioneine and is responsible for transporting ergothioneine from the intestines to other tissues in the body. Research has been looking into the potential for ergothioneine to mitigate neurodegenerative diseases due to patients with various diseases such as Parkinson's having lower levels of ergothioneine in their body compared to patients without these diseases. Conventional agriculture practices have decreased the ergothioneine levels in fungi and plants. For example, tillage of the soil, and these methods disrupt the fungal mycorrhizal systems, interrupting proper symbiosis between the fungi mycelia and the plant rhizomorphs. Mycelium is the primary resource for ergothioneine and how it transports it from the fungi to the plants. A few very common mushrooms that are very easily accessible and contain high amounts of ergothioneine are Hericium erinaceus, which is lion's mane, Agaricus bisporus, which is white button mushrooms or portobellos, and Pleurotus austrius, oyster mushrooms. I would like to mention a couple of other pharmaceutical fungi chemicals that I highly encourage you to look more into and do your own research on. First is ergosterol, which is like cholesterol but for mammalians. That is not necessarily a bad thing when it is in the right amounts, because ergosterol has been shown to benefit cellular integrity and cell membrane health. The other is ergotamine, which is already a pharmaceutical medicine that is used to treat cluster headaches by blocking pain receptors and narrowing blood vessels. Another chemical that has gained efforts to be studied as a pharmaceutical medicine is fungal terpenes. In various fungal species, it has been shown to benefit the human skin, the skin being a main defense barrier when it comes to negative outside influence. And fungal terpenes have the therapeutical significance in dermatology by modulating cell signaling pathways, influencing gene expressions, and interacting with key molecular targets. There's a number of different types of terpenes. I'm just going to name off a couple, such as monoterpenes, sesquiterpenes, diterpenes, sesterpenes, triterpenes, tetraterpenes, and polyterpenes. Many different mushrooms and fungal species have beneficial terpenes, but two of the most common are Ganoderma lucidium, which is reishi, and Enonotus obliquus, which is chaga. There is some very good literature out there on fungal terpenes, and it's definitely well worth the read. Again, I will provide a link in the video description. In conclusion, fungi have become anti-masters and have evolved in such a way that they have a defense and strategy for just about anything that tries to harm them. The mycelial network of the fungal species are intelligent and much stronger than what we think. On that note, I think that we as humans, being that we share 55% of our DNA with fungi, meaning that they have a lot that they can offer and a great gift to us, whether it's something like the common cold or a massive worldwide virus, I believe fungi can be a powerful ally for us all. Thank you very much for watching.